subject.
Right. What do you want?
Is this recording?
Right. Oh, he's trying to say he can't see me.
Oh, yeah, it is recording. All right.
Oh, my God.
I didn't see it. Okay, yes, you can go. Yeah, give me your book, and I'll let you go. All right, so what we're going to do today, everybody with me now? Yeah. So we're going to add, subtract, multiply, and divide polynomials. All right, so that's what we're going to do. So let's do the first one, which is addition. That's probably the easiest, I guess. Yeah, it's probably the easiest out of all of them. While I sign Ray Romano's book to go to the bathroom. All right, now that's on YouTube. All right, so let's do. We're just going to start off with some examples. Okay, I'm not going to go through any kind of like teaching. The teaching is just going to be through examples. So let's do one. This is actually example 4. If you were to look in the book, it's example 4. All right, and this is adding polynomials. So write this down. It's 8x cubed, and then we'll talk about it before we actually add them up. So 2x squared plus 6x. And you say, wait a minute, it says adding polynomials and you got minuses in there. Well, subtraction is kind of like addition. It's just adding the opposite. Plus 3x to the 4th. It's supposed to be a plus. That's supposed to be a 4. Let's make it look more like a 4. Oops. There we go. Come on. All right. There we go. 3x to the 4th minus 2x cubed, 2x cubed plus x squared plus x. All right. That's one problem. It's really not so bad. All right. It looks terrible, looks awful, but it's really not so bad once you break it down. And that's what we're going to do right here. Okay, we're going to break it down. I'm going to show you how to add these things together. Do you remember in Algebra 1, they always said in Algebra, you always add like what? Terms. Okay, and we talked about what terms were. Well, did we? No, we talked about the polynomials. Talk about the terms, the like terms. When I say a like term, the number out in front, do you remember what that word is to represent the number that's out in front of this? Starts with a C. O-E. Coefficient. Very good. I-E-N-T. All right, that's a coefficient. Now look, the coefficients can be different. So when we say add like terms, the coefficients, the number out in front, okay, that can be different. That's fine. It's like this. It's like adding 2 apples plus 3 apples, right? The 2 and the 3 can be different, right? As long as they're both what? Apples. You follow me? So let's take it to algebra. 2a plus 3a is what? 5a, right? 2 apples plus 3 apples is 5 apples. Agreed? Okay. So what you do is you take the terms that are the same, and then you only add up the terms that are the same. And then what you're going to do is you're going to add the coefficients and then just stick the term in there. All right? What in the world did I just say? Well, let's take a look. This has an x cubed in it. So what we do is we look to see which of these terms has an x cubed in it. The 2x cubed. So what I'm going to do, actually, let's do this first. Sorry. I like to start with the highest power first, okay? Let's start with the highest power. It wouldn't be wrong if you started off with the x cubed, but it just looks neater, okay? It looks a little bit better. We put it in descending order is what they call it, from the highest power down to the lowest power, okay? Which one of these has the highest power, the highest exponent? The 3x to the 4th. Do you see any other x to the 4ths here? No, you don't. Okay, there's only the 3x to the 4th. I'm just going to keep this in red. Can you see the red okay? No. You can't? Okay, glad I asked. All right. So it's positive, so it's 3x to the 4th. Now, when you have a big, long polynomial like this, what I like to do is just kind of mark it off so I know I'm done with it. Okay? That kind of takes away some confusion. All right, now, what's the next highest exponent, or the next highest power that we have here? Yeah, the x cubed one, right? The x cubed. Now, what we do, in order to add, we have to see if there's any other x cubes. Now, there was no other x to the 4th, so I just left it there, okay? But there's one other x cubed, isn't there? Yeah. So I'm going to circle them. There's this one, and there's this one. It's not just a 2x cubed. What is it? It's a negative, or a minus 2x cubed. That's very, very important. You got to look at the sign before the coefficient, right? Coefficient's that number, right? That number before it. So we've got it. And so basically, it's really simple. Even though this is called addition, we're kind of subtracting, aren't we? Or you're adding a negative, which is subtracting. So it's 8 minus 2. What's 8 minus 2? Is it positive or negative? So we put a plus since it's positive. And then I put a 6. And now you just tag on whatever the term is. What's the term? It's x cubed. See how easy this is? Okay? So I'm done with that. You don't have to do this, but I like to do that, especially when you have a whole bunch of them. I just cross them out. All right, let's just continue with the rest of it. What's the next highest power? Squared. Okay, now this is a minus. Don't forget that. Okay, so you've got a minus 2x squared. Where else? And a plus x squared. What's the coefficient when it's just x squared? It's 1. There's a 1 out in front of it. Okay, so now we add them up. But this time, this is a minus, so we think of it as negative 2. So this is a negative 2. This is a positive 1. What's negative 2 plus 1? Negative 1. So I put a negative 1. What's my term? What's the variable? It's x what? Squared. Everybody with me? Do you really need the 1 there? You don't need it. You can put it there. It's fine. I just did it so you saw what negative 2 plus 1 is, okay? It's negative 1. It looks a little cleaner if you don't have it, but it's fine to have it there. I'm done with the x squared, so I mark those out. What's the next one I'm going to do? Just the x, right? The x to the first. Okay, we had x to the fourth, to the third, to the second. Now we're going to do x to the first. So again, what is this? Always take the sign in front of it. That's very important. That's a positive 6, and this is a positive what? 1. You see it? That's easy. 6 plus 1. Positive 7. And what's my term? It's x. Started off looking really ugly, didn't it? But now it's not so bad. We kind of tamed it a little bit, didn't we? What else is left? Just the negative 2, okay? We call that a constant when there's no variable next to it. Technically, you could say it's x to the 0, because what's x to the 0? It's a 1, right? It's just negative 2 times 1. But, you know, we don't really care that it is, but sometimes you do. So what are you left with? Just this, so you just stick a minus 2. Right? There's nothing to add it to. So we only added the like terms. You can only add up the x to the 4s together. You can only add up the x cubes, the x squareds, the x's together. Okay? If you had another number in here, like a plus 5, then you would have added the negative 2 to the plus 5. We don't have it. All right? And that's your answer. That's it. It's weird looking. It's long. But really, was it difficult? No, it wasn't. Okay? It really was simple addition. It really was. You just have to know which ones to add together. You cannot add the x to the 4th to an x cubed. That's like adding apples and oranges. You've heard that expression a million times, haven't you? You can't add apples and oranges. That's what that is. That's what x to a 4th is, and that's what x to the 3rd is. They're apples and oranges. You can't add them together. They're different terms. We good? Yeah. All right, let's move on. Let's do a subtraction problem. And this is example 5. And you're like, well, Mr. Hamrick, we did a couple subtractions in there, right? We did a minus in there, but this is a little different. So this is kind of long, so let's write it down. So I've got 3x to the 4th minus 4x cubed. There's really only one thing that's a little bit different with this than what we just finished doing. That's a 3, x cubed. It's minus 4x cubed. It's kind of ugly, but that's what it is. It's in the book. 3x to the 4th minus 4x cubed plus 6x squared minus 1 minus, another parentheses, it's 2x to the 4th. I'll read it off in case my handwriting's too sloppy. Minus 8x squared minus 6x and then plus 5. All right. Let's move it up so we can see it a little better and give me some more room to work. Let's move it down just a tad. Okay? I'm going to do, can you read that yellow? Is that yellow good? Yeah. Okay. So what we're going to do here, what's different about this? Well, the parentheses, obviously, right? The parentheses in front of this one, did we really need the parentheses in front of this? Not really, because what's my sign out here? If there's no sign at all, what is my sign? It's positive, okay? So does the positive change anything? No. So this stays exactly the same. All right, so 3x to the fourth minus 4x cubed plus 6x squared minus 1. You're like, well, why did I even put the parentheses in the first place? Well, there could be something out there. Okay, maybe they put a number out here. Okay, maybe they put a negative out there or something like that. Then you'd have to do stuff with it. Okay, now this one is important. What's out in front of this parentheses? This negative. So that negative, give me good math words. Starts with a D when you go like this. Distribute, right. You learned that in algebra, right? So you distribute the negative through here. So basically, what does distributing a negative do to all the signs? It makes them opposite. No, it makes them opposite. Okay, opposite whatever the sign was to begin with. So what is the sign of this to begin with? This 2x to the fourth is positive, but this negative is being distributed. It's like a negative 1, right? It's like you're multiplying everything by a negative 1, okay? So you're going to distribute through here, through here, through here, and all the way through there, okay? So really all it does is just changes the signs of everything in there. Again, they could make it more difficult and maybe put a negative 5 out in front. So you'd have to multiply everything by a negative 5. In this case, they didn't put a number. It's just a negative. So what's this going to be now? Minus 2x to the fourth. What's this going to be? Plus, right, because we changed the sign. That's what negatives do, right? They make the opposite sign. So it's 8x squared. What's this one going to be? Plus 6x, and then this turns into minus 5. Now, this problem is just like what we did in the first example. You with me? That's the only thing really we did different on this, okay? We just distributed the negative, which really wasn't that bad. All right, let's do this a little quicker than we did the other one. We have 3x to the fourth, and what other x to the fourth? Just this one. So it's 3 minus 2, which is what? 1x to the fourth. I still like to mark them out just so I know I'm done with them, so I don't accidentally add stuff together that I shouldn't, okay? What's the next one? Cubed, right? I got a cube here. There's no other cubes, right? So I just write it down. And I'm done with that one. The next one would be squareds. I got a 6x squared, right? And I got a 8x squared. So it's positive 6, positive 8, which is positive 14x squared. I'm done with that one. And then we got what? An x. Do I have any other x's just by themselves? Nope. So I just write it down. Plus 6x. What else do I have? I got this negative 1 and negative 5. So it's negative 1 minus 5. Do you know how to do that? Negative 1 minus 5. You add the opposite. Remember that? Add the opposite. Add a line, change sign. Right. That's how you learn. That's a cute little way. I don't really go by the little cute little things. I just kind of say what they are. But the cute little things probably has you remember it better. I don't know. But if I always said just add the opposite, you would understand what I mean, right? And that's just minus 6. And that's it. That's your answer. You can't simplify it any more than that. We've added up all our like terms. We good? Yeah. All right. Let's scooch this up. Everybody got that? I'll leave it right there just in case. All right, let's do another one. We got one more, and that's it. We're actually not even dividing today. How about that? I put division. I thought we were, but I don't see any division. Oh, we have a whole another section where we do division, but not today. Because that really gets, that really can get a little weird. So example 6. So we're going to multiply. I tell you what, I'm going to do one that they didn't put in the book just for fun. All right? Let's go 2x. I'm just going to make this up off the top of my head. 3x. I'll put minus 2. Okay? Now, what are we multiplying? What the words that we talked about day before yesterday with the nomial thing? Okay? What is this first parentheses? There's 2 terms, so it's a binomial. This one right here is 2 terms, so it's a binomial. So when we multiply binomials, math teachers came up with, I don't know who came up with it, to tell you the truth. I have a feeling it's math teachers. But they came up with a word, a mnemonic device. Do you know what that word means? It means you remember it because the first letters stand for certain words, okay? So what is the word that we use when we are going to multiply this? Say it. FOIL, right, FOIL. Remember that? First, outside, inside, last, okay? That's what that stands for. What does that mean? That means the order that we multiply things in. So let's take the first one, and we're going to multiply it by the first one over here. You see it? That's the F. That's the F in FOIL. The outside. Well, what are the two outside ones? Well, this is the outside, and this is the outside right there. That's the O. Right with me? Yeah. It's basically distributive property, isn't it? We're just taking the first one, and we're multiplying it by both of the things in here. And then we take the second one, the plus 1, and we multiply it by everything in here. So it's basically just a fancy thing for distributive property. So what about the inside? That's the inside. That's the I. And then the two last ones are those two right there. That's your L. There's your FOIL. Okay? That's the order that you multiply. So we're going to do, I'm not going to write down like 2x times 3x. We're going to kind of do that in our head though, okay? So look, 2x times 3x is what? Is it 6x? Very good. It's 6x squared because it's x times x. It's 2 times 3, and it's x times x. X times x is x squared. That's the first. Got it? Let's do the outside. It's 2x times negative 2. It's a positive 2 times a negative 2, which is negative 4 what? X. Okay? The inside, it's positive 1, positive 3. Multiply those together, you get a 3, and then it's just an x. And then the last terms, it's positive 1 times negative 2, which is negative 2. Are we finished? Do I keep my answer like that and circle it? No, because you got to add like terms, right? Just like we finished doing, except this one's way easier, isn't it? So this is 6x squared because there's no other x squareds. These two right here, we're going to add those. So what's negative 4 plus 3? Negative 1x, right? If you want to put the 1 there, it's fine. You don't need it. And then just stick a minus 2, and that's your answer. Okay? That's your basic everyday FOIL method problem. But it is distributive property. I just made this one up, so that's technically not example 6. This one is technically example 6. It's kind of like it, but it's not FOIL. You're going to use distributive, and so let's write this one down. It's 2x plus 5 and x squared minus x plus 2. You can't really do first, outside, inside, last with this, but you can do distributive. Take the 2x, multiply it by everything in this other parentheses. So watch, I'm going to do these little lines. 2x times this, 2x times this, and 2x times this. But that's not all, is it? There's more, isn't there? There's that 5 you got to multiply through here. So I'm going to take that 5, multiply it by this, and by this. See what I'm doing? Just doing distributive property, okay? Except I'm doing it to 2 different things, right? I'm taking 2 things and distributing through 3 things over here. So this is a binomial times a trinomial, okay? Somebody want to get the door? All right, so let's do the first 2 things. The 2x times x squared. Let's multiply that together. What's 2x times x squared? It's 2. And then x times x squared is, everybody up here, x cubed. Okay, because time's running out. Got like a minute. All right, let's do the next one. So it's 2x times negative 1. So 2 times negative 1 is negative 2. And then x times x is x squared. Very good. You got it. One more with the 2x. So it's 2x times 2. Thank you. So it's 2x times 2, which is positive 4 what? X. We're only halfway done, though, aren't we? We got to do the 5 now. So let's do the 5. 5 times x squared plus 5x squared. Okay, and the 5 times negative 1? Why'd you take that away?
I have a question.
Okay. Let me finish this because the bell's about to ring. I got the 5x squared right, minus 5x, very good. And then the last one, plus 10. Are we finished? No. Let's add like terms. Any x cubes? Nope. I'm done with that one. Any x squareds? Yep. Negative 2 plus 5 is positive 3x squared. So I'm done with that. The x's, it's positive 4 minus 5, which is negative 1. So it's just negative 1x. Done with those. And then there's nothing to add with the 10, just plus 10. That is your answer. Okay? And that's how you do it. What's that? We're going to do division later. Division is a little more complicated, okay? So we're going to save that for another lesson. Here's your homework. Your homework is R.4, and this is A, right? We haven't done any R.4s? Okay. So this is A, so we're going to do page 48, 27 to 45 odds. 27 to 45 odds.
48.
All right, everybody got that? It's right there on the board. It's 27 to 45. That's why I wrote it down. All right, have a good day.